Hi. In the earlier two demo videos, we saw how the one-dimensional cutlist optimizer works, both solver-based solution, and another video is about algorithm-based. If you have watched it, if you have not watched it, I have added the link to the video's description. Please watch them before watching this video. Cutting optimization is at the heart of the material efficiency. Whether you are cutting pipes, rods, or done boards. But when it comes to choosing a 1D cutlist optimizer, should you go with a solver-based method or an algorithm-based method one? Let's compare both approaches so that you can decide which one fits your workflow. In any cutting process, the goal is simple. Cut stock material into required lengths while minimizing the waste. This is known as 1D cutlist stock problem, and it's surprisingly not simple. Different optimizations solve in different ways, which can lead to very different results. Let us start with the solver-based optimization. This approach uses mathematical solvers like linear programming, integer programming to find optimal solutions. It builds a mathematical model of your problem, the lengths you need, stock size, and the cutting constant, then searches for the best possible arrangement with minimal waste. This is the solver-based solution we have seen in the earlier demos. So now I have the another one. This is the algorithm based. I have prepared some test data so that we can compare the results between both algorithm based and the solver based ones. So we can compare and see the how it goes. So now I have added the first one. This is the one with a stock length of 5600, and these are the different cutting patterns required, the number of pieces, and this is now I am running the solver based. I clicked on generate. It's preparing the patterns, then generating it. Now this is the generated pattern. So as you can see, for the first bar, this is the 4 cuts that it can take, up to 6, 5, 6, 1. Again, it's a different one. So these are the cutting patterns, and as for this one, the solver based one, total stock bars required is 133. Total wastage is 9080. Now let's go to the algorithm based one. I have the same set of data here, the same bar length. I'll click on generate. I started preparing the, it's completed. You can see 9080, and the total wastage is, you can see 9080 is the total wastage and 133 bars required. It is the same result that we got between both of them. Now let's go with the another set. This is the next set. I copied it. Go to the, this is a solver based one. I'll clear this data. Copied and paste it. The bar length is 150. Now I'll click on generate. Yeah, it has generated. You can see whatever we required and obtained are matching. So the total wastage is 655 and the bars required is 85. Now let's go to the algorithm based one to run the same. I'll delete them. Copy it paste special, the length is 150. We double check, it's 150. Click on generate. Now you can see it is the 85 bars required. Let's compare it with the, it is the same 85 bars required here. Here 655 is the wastage. Let's see what is the wastage here. It's the same 655. It's almost performing the same way, but technically the optimal the model that uses the solver is always a better performer than the algorithm based one. Now let's take another one. Yeah, this is very interesting one. Let's take this one. This gives red because the bar length is less than the actual required length. So now I'll put 6000. For this one, I'll generate. So you can see that solver is not able to provide a solution to this. So now let us try with the algorithm based one. $6,000. Now I clicked on generate. Now you can see that this is algorithm based is providing a solution. But the solver based one could not, it failed. For some of the complex cutting patterns, solver fails, it cannot give. But algorithm based gives, but you cannot say it is 100% optimal, but it gives to around 95% of 95 to 100%, in between that range. In some cases maybe it is 90%, but it gives the better optimal solution. It gives the better optimal solution. There is one setting we can say. Let's try with this one. Two four zero zero. Generate. This is the algorithm based one. Now I am generating first. So 6200 is the wastage. Now I will do the same thing with the solver based. Bar length is 2400. Generate. Now you can see this one. This is a 3800 is the wastage in the solver based one, and the algorithm based one is 6200. For the algorithm based one, 48 bars are required, but for the solver based one, 47 bars are required. So solver based is always an optimal solution, but we cannot say the algorithm based is always optimal. It may sometime below optimal, but it provides a solution. Even if it is a below optimal, it generates between 95 to 100% of optimal, not too far from the optimal values. So based on this, hope you can make a decision which one is required for you. As per our suggestion is to keep both the tools. First, you can use the solver based tool. So if it is not, if the capabilities are not there with the solver, because there is a limitation for the solver, it cannot take too much complex inputs. So in that case, if the solver cannot provide solution, it gives a message solver is not capable of doing it, then you can go for the algorithm based one, because algorithm based always gives the results almost near to the optimal, not too far from there. That's all about this video. Thank you for watching. If you need any further information, you can please visit our website excelonlinehelp.com and write to us. Thank you very much.